So circles aren't always given in standard form, but we like this form because it's very easy to graph. It's very easy to see the important information, the center and the radius. It's just the nicest form to have. Now, if they're not given in standard form, then we can use the technique called completion of the square. Now, how this works is we need to have it in this form where we have the x's together and the y's together. So I'm going to rearrange this to be x squared plus 6x plus y squared minus 8y equals 0. And now I can do this process. So the first step is going to be looking at the number in front of the x. We're going to take this number, which is 6 plus 6 divided by 2, always divided by 2. Then take that number and square it. Okay, same process for the y. The number in front of just the y term, it's going to be negative 8 divided by 2, so negative 4, and then square that number. We get 16. Now 9 and 16 are the key numbers here. 9 we're going to add to both sides, and I'm going to add it right next to this x term. And 16 I'm going to add to both sides, but next to the y term here. Okay, that's going to give me x squared plus 6x plus 9 plus y squared minus 8y plus 16 equals 9 plus 16 is 25. And now I can factor these guys. So this thing will actually factor down into, it's going to be x and then whatever this number is here. In this case, it was plus 3, so it's going to be x plus 3 squared. This term is going to factor down into y and then whatever this number is here. So y minus 4 squared. I recommend you try that. Actually factor these things down and see how it works. Okay, so this first one's going to be x plus 3 squared plus y minus 4 squared equals, I'm going to write 25 as 5 squared. And I do this because now this is in standard form. We have the center negative 3, 4 with a radius 5. And now let's graph these both of these equations and show that they are actually the same circle. All right, so I have this purple circle is the original equation, the negative y squared plus x squared plus y squared plus 6x. That was what we got originally. And then we found this equation here, which I've written here. And you'll notice that if I turn this on, it completely overlaps the purple circle. So they are, in fact, the exact same thing. This, of course, is nicer because you can actually see what the center and the radius is. This one, you cannot see that information. So that's where the standard form really shines. Okay, let's try another one. All right, once again, let's get this in standard form. So x's together and then the y's together. And I'm going to move this 1 to the other side by adding that. Okay, now I'm going to look at the number in front of the x term, take that number and divide it by 2. This, of course, is just negative 5 halves. Then I'm going to square it. That's going to give me 25 fourths. Same process, look at the number in front of the y term, which is plus 3 over 2. That's, of course, just going to be positive 3 halves. And 3 halves squared is 9 fourths. Okay, so I'm going to add 25 fourths to both sides. And then add 9 fourths to both sides. Always add the number after you square it. That's what you're looking for here. Okay, it's going to give us x squared minus 5x plus 25/4. And then 25/4 plus 9/4 is going to be 30. Well, it's the same. This is the same thing as 4/4 here. So we got 25 plus 4 plus 9. That's going to be 13 plus 25. So 38/4. All right. And now this thing will factor down into x minus 5/2 squared. This thing will factor down into y plus 3/2 squared. And 38/4, this is the same thing as the square root of 38/2 squared. I just took the square root of 38/4 and simplified it down. So we have our center is at 5/2, 5/2 negative 3/2, and our radius equals the square root of 38/2. All right, let's graph this. All right, and here I have the first equation graph. It's in purple here. And if I graph the equation that we found, which has the this radius here, graph that, and you can see it is the same circle overlaid on each other. So we did it correctly. Give it a try in number 7. All right, for this equation, it's going to be a little bit different because we have a number in front of the x and the y term. But the process is going to be very much the same. There is extra steps we're going to have to take, however. First off, we need to get the x squared x, y squared y to one side and the numbers to the other side. So I'm just going to do that by subtracting all of this side over to the other side. And then moving the positive 13 to this side. So not all of this, just this portion. And positive 13 to the other side. So that's going to give me negative 5x squared minus 20x minus 5y squared minus 14y equals 38 minus 13. It's going to be 25. Yep. Whenever there's a number in front of the x squared and the y squared, they have to be the same number as well. If you don't actually have the same number, then you actually are going to get a different kind of shape, something like an ellipse or a hyperbola, but we're just looking at circles here. These are the same, so we know it's going to be a circle. I'm going to divide negative 5 out of the first two terms and negative 5 out of the second two. So I get x squared plus 4x minus 5 y squared plus 7/5 y equals 25. And now I can actually divide both sides by negative 5. Doing that gives me x squared plus 4x plus y squared plus 7/5 y equals negative 5. And this is the same kind of process as the previous problem. So we're going to complete this square. So we're going to go this positive 4 divided by 2 is positive 2. Positive 2 squared is 4. Then this positive 7/5 divided by 2 is positive 7/10. Then square that is 49/100. Okay. So those numbers we're going to add and subtract. the positive 4 and the positive 49/100ths. So we're going to get x squared plus 4x plus 4, y squared plus 7/5 y plus 49/100ths. Negative 5 plus 4. I added 4 to this side, so I need to add 4 to this side. That's where this first one came from. And then since I added positive 49/100ths, and you do the same to the other side. So with this, I have not changed the problem. Also, this thing factors down into x plus 2, this number plugged into there, squared. And the y term, that whole thing factors down into y plus 7/10 squared. This thing just plugged right into there. Okay, I get x plus 2 squared plus y plus 7/10 squared. Negative 5 plus 4 is negative 1. Negative 1 is the same thing as negative 100 over 100. So adding that to this one, we're going to get negative 51/100ths. So I've just realized that I made a mistake here. I can see here that I have a circle equal to a negative radius, and that should raise some flags. The circle cannot, a circle is a distance, and distances can't be negative, so this can't be possible. It can't have a negative radius. And that tells me I must have made a mistake somewhere. And that, of course, happened up here. For some reason, I divided 14 by 2. I don't know why I did that, but this is actually 14 over 5. So it's going to change this to 14 over 5 over 2, or 14/10, which is the same thing as 7/5. I think that's where I got my 7/5 from. Of course, 7/5 squared is going to be 49 over 25. So that's going to end up changing this one to 49 over 25. And this one here to 49 over 25. Which will change. We still have this negative 5 plus 4. Of course, it's going to change this one. It's going to now be y plus 7/5 squared. Y plus 7/5 squared. And it's going to be negative 1. Negative 1 is the same thing as negative 25 over 25. Negative 25 plus 49 is going to be positive 24 over 25. And so we can see that the center is at negative 2, negative 7/5. And the radius is the square root of this thing. Square root of that thing, of course, square root of 25 is 5. Square root of 24 simplifies down to 2√6 over 5. I think that's correct. And now we can graph this to make sure we've done it correctly. So here I have the first statement. That's the exact triangle or circle that we started with. And then I have my new equation here, this one right here. This is x plus 2 squared plus y plus 7 squared equals 24 over 25, or this thing squared. It's the same thing. That's going to give us this circle. And if I graph the circle that we found, it overlaps it completely. So this is the correct squaring. I just wanted to show you that to show how you can error check or make sure that you're doing this kind of thing correctly. Of course, if you graph them, you can always check your answer with the original and that to make sure you've done it correctly.